right, so hopefully this topic will give you a little bit of a breather from all of the intense integrals we've been doing lately. This should just be a review. We're going to talk about limits today, and in the next lecture, we're going to talk about L'Hopital's rule. So we just want to review limits. This should be something you've probably had before because when you were first exposed to derivatives, we defined a derivative in terms of a limit. So before introducing derivatives, you probably talked about limits. So, so a limit is just, I think of it as kind of sneaking up on a value, right? For example, if we have a function, let's say 3x, I'll just write it here, 3x, and we want to know the limit as x approaches 2. Well, in this case, we can just actually evaluate 3x at 2 and get a value. We can actually go there. But we could also figure it out by kind of sneaking up on it. We could try 1.9 and then 1.99 and 1.999. Or we could go the other way. We could do 2.01 and then 2.001, or, and we could sneak up on it. And either way, you'll see that it, from either the right or the left, this limit approaches 6. And in this case, we could actually just evaluate 3x at 2 and get 6. But sometimes we can't. We can't go there. We can't just go straight there. So, for example, if we have this function, this e to the 3x minus 1 over x, and let's say that we wanted to evaluate the limit at 0. So, we can't just put in 0, right? Because then we get something over 0. In fact, we get 0 over 0, right? If I put in 0, I get 3 to the 0, which is 1, minus 1 to the 0, over 0. And that is not going to work, right? That's undefined. We can't just put in 0. But we can sneak up on 0, right? So if I sneak up on it from the left, and I put in some values, like I put in negative 0.1, I get 2.5918178. Okay, I've taken it out to 7 decimal places there. That'd be plenty. And then I can get a little bit closer to 0. So if I get a little bit closer to 0 and evaluate it at negative 0.01, I got 2.955 4466. 4466. Okay. And then I could also sneak up on it from the other direction. All right. So if I evaluated this function at 0.1, I get 3.4985881. Okay, and I get a little closer. Evaluated at 0.01, I get 3.04. Let's see, 54534. All right. So if you look at this, it kind of looks like it's maybe about 3. Now I could evaluate a few more points. I could put in 0.0001. I could put in 0.00000001, and I could get a little bit closer. But just from this information I have, it looks like the limit as x approaches 0 of this e to the 3x minus 1 over x is equal to 3. All right, so that's just to give you an idea of a limit. And so, and that's really all I wanted to talk about in this example. We're actually going to revisit this example in the next lecture. But so by this estimation, I could say, okay, this is just an estimate, right? I haven't actually proved it, right? But it looks like it's going to 3.